welcome to everybody interested in maybe starting to do some EME. It would be very, very nice if we could have a couple of more guys come onto the EME bands. At the moment, there's only three of us doing 23 cents EME in South Africa. That's myself, ZS6JON, and Bernie, ZS4TX. So one on each of those three divisions, and nobody else. 23 Cents is actually one of the easiest bands to do EME on. Um, but just the activity levels are just so low from ZS. And I especially made this presentation a really easy one so you can just get going and not worry about the technical aspect of it so much. You can sit and do number crunching all day long, but people have proven just get on there, use what you can get your hands on, and start operating. So this is where this solar cooker has actually developed and came from. Um, Everybody's looking for a dish, and where do you find your dish? Finding dish for EME is one of the most common and difficult tasks for those interested in microwave bands on 23 centimeters up to 3 centimeters. So unless you find a local surplus commercial dish of the size that you want, your options become limited and they can become very expensive if you have to buy that. So what do you do? Well, how small can you go then to have successful 23 cents EME? Bob KA1GT discovered the solar cooker. Now, the solar cooker is also sold in South Africa. I'll quickly grab the screenshot of the website for it. So it's www.sunfire.co.za. You'll find it on their website. And you can see there's three different sizes available, three different prices as well. And they're not expensive. I'm sure they are. The middle one is in the ballpark of buying a sort of a 6 meter, maybe a 6 meter, 3 element yogi or a 4 element yogi. That's the price of the middle one. The one on the right, the 3,000 rand one, is a little bit more expensive, but it is very affordable. It's not something out of range for most of us that we can do. You might find other dishes as well on other websites. These are the panel dishes, but because they're made for solar cooking, it's one of those things where it's not made for something. You can find it cheaper for something else. So the solar cooker, if you buy it, it ships like this. It comes in a box. And then it's a panel assembly that you have to do to get the thing up and running. After assembling the panels, you'll see on the front of it, you've got this very bright mirror-like stickers, which you can then peel off. So once peeling off these stickers, that's creating the sun heat, you're basically left with the dish, the parabolic dish that we're going to use for EME. Now, the one that they buy in the States from AliExpress, that's the most common source for them, is the 1.5 meter dish. Now, 1.5 meter, guys, is not a big dish. If you stand next to it, it's probably going to fit you maybe to your chest. It's not a huge dish. It's easy to work. It's easy to manipulate, easy to pick up and handle by yourself. Obviously, you're not going to do that. You're going to put it on a sturdy support to allow you to steer the dish. But then the mechanical work starts. So getting the dish is one thing, and then the mechanical work starts that you have to strengthen the dish because we're going to put a feed onto it. And the feed is not just going to be a small little LNB. So here's just an example how the guy just strengthened it. It's not rocket science. It's just a bit of aluminiums and screws that he used, and then put on his support arms for his feed. There's basically two types of feeds that the guys are using. The one on the right-hand side is the one with the leg supports where you're going to put your LNB or your feed, we call it a septum feed, into that little cage, and you're going to clamp it in there. You can move it in and out to get your maximum sun noise. We normally do measurements on the sun to get your maximum sun noise. And when you get your maximum sun noise, you sort of know that you are at your focal point for your feed. The other one on the left-hand side is using a through feed. So he's developed his system that has got a pole going through the dish, and you'll see what the other side looks like now. So on the left-hand side, you've got that pole coming through the dish, and then he mounts the septum onto that. On the left-hand side there, you can also see his preamplifier. On the right-hand side, that blue coax, that's for the transmitting side. So when we do EME on 23 SEMS, we use circular polarization, left and right. So that's why we got two ports. So the one is for the receiving and the other is for transmitting. And obviously you'll need a coaxial relay to switch between the two of them for transmitting and receiving. This coaxial relay obviously needs to be switched with a sequencer. More about that just now. But yeah, you can decide what type of system you want to use. You want to use the brace type feed on the right hand side, or the through center feed, which is normally a non-metallic type pole that they use, a fiberglass pole that goes through it, and that supports the feed. Then these feeds, these septum feeds, there's a very nice layout or design on OK1DFC's website. You can just Google septum feed and you'll find how to make it. It's not hard to make it. If you know anybody with a laser cutter, you can just give him dimensions. He can cut it for you and you just put it together. It's not that hard. We've all done it. The ones that do EME. And if there's a couple guys that want to do it together, obviously we can put in a batch and make 3 or 4 of them at the same time and then just ship it to you and you can then assemble it. So it's just plates of aluminium, probably about 1.5 millimeter thick, that you just screw together with the feed in the middle. Right, so that's basically the feed. More about that just now as well. The type of support that some guys use for it on the back, you can see on the left-hand side, this guy's just gone for the wooden support. I'm just sort of giving you guys what you can do as a DIY system. You don't want to invest lots of money into getting this to work. So DIY systems works well. On the right-hand side, you'll see that's the through the middle feed support. So it's a fiberglass pole and then a 3D printed holder that holds the feed, and then the feed sits on top of that. Those feeds and those 3D printed, all of that can also be bought. You can ship it from Europe. If a couple of guys do it together, it becomes quite affordable instead of each one shipping his own. Or you can get a template and 3D print it yourself, of course, if you've got a 3D printer. Right, now, the support for these 1.5 meter dishes varies quite a lot. Some of them has made these industrial type tripods that they use for land metering. That's the one on the left-hand side. And it's got a small little azimuth elevation gearboxes that can lift and move it left and right. And then you can see he's got all his equipment in that little pelican case. So the radio is there, the amplifier is there, the power supply is there. So you take that out if you want to operate it. You put it in your spot where you want to be. You calibrate your directions, and off you go. You can operate. The next one in the middle, he uses that little trolley base because you can't leave it outside. So at night, or if the moon is not off, if it's not operating, he just takes that whole trolley and moves it into his garage, and it stays there until the next time that he wants to operate. And then on the right-hand side, you'll see it's a similar sort of concept. This guy's just made a more permanent, sturdy support for it. It's a small little tower with his rotators on top of that to turn it in the azimuth and the elevation plane. All of them really, you can see those white cases, those boxes. They keep all the equipment very close to the dish. So the amplifier and everything is very close to the dish to minimize losses, of course, at these high frequencies. If you can have the amplifier as close as possible to the dish, then you have minimal losses. If you've got a 100-watt amplifier and a 20-meter run of coax, you lose 3 dB. Only 50 watts will get to the feed. So we want to get the amplifier as close as possible. So a lot of these amplifiers, I'll get to them just now as well. You'll see on the next couple of slides. They only need about 3-4 watts to drive to get the full power out. So most of our radios like the IC910 and the IC9700, they put out 10 watts. So if you run 8 watts, 4 watts will get to the amplifier at the dish, and you'll get full power or most of your full power out at the feed to make your contact. So yeah, it's not that difficult to do, guys. Everybody can do this. And you'll find that you've got a lot of the equipment already to actually do this if you start scratching around. I think the hardest thing to do is actually to get the elevation actuator for the elevation and the gearbox for rotation, and then getting feedback to tell you where you're pointing, because that dish needs to track the moon. Obviously, the smaller the dish, the wider the beam width, and you don't have to be so accurate. At 10 gigahertz, for example, with that same type of size dish, you have to be within 1 degree. If you go 1 degree off the moon, you miss it. So this was a little bit more lenient. You can maybe be 2 or 3 degrees off, and you'll still be able to hit the moon with the smaller dish on the lower frequency. Right. So mechanical work, just like all directional antennas, you need accuracy and high degree of accuracy. The dish needs to move in the azimuth and the elevation plane, so gearboxes and actuators needs to be incorporated. There shouldn't be any slack of the dish when the wind blows. So it shouldn't go off the moon if there's a bit of breeze coming up. These dishes are sort of there for catching a lot of wind. They're like big ears and they catch a lot of wind. So they have to be quite sturdy so it doesn't move if the wind blows. And then you need to make feedbacks for where you're pointing. Simple feedbacks from variable resistors, potentiometers, and then we go up into other better type of actuating and sensor development that you can buy. Some absolute encoders. The incremental encoders don't work so well. Every time you switch the dish off or the power off, it loses its position. But if you can get an absolute encoder, then it remembers the position where it was at. And then, of course, low loss cable. Not LMR 400. LMR 400 doesn't really qualify for low loss cable. You could use it on the RX line. DX line also if you're running a very short line. But if you can get something better than LMR 400, half-inch helix, there's quite a lot of that around in ZS, or even a 5/8 or 7/8 helix, that very thick coaxial cable. There's quite a lot of that as well around in helix, especially if you get to know some of the commercial guys at the telecom sites and so forth. They're always scrapping coax. So low loss coax is a need to have as well. On the electronic side, most of us uses IC910s or IC9700s or transverters. So the radio is fine. If you just want to listen, you want to start listening, you don't have to do much. And even without a masthead preamplifier, you'll be able to pick up the big stations. The moment you want to start transmitting as well, you need to include a sequencer. Now, a sequencer is quite easy to build with a couple of relays and PICs, or even Arduino-based sequencers. There's a couple of them as well. I can also help you with that. I've built a couple of Arduino-based sequencers. Low noise amplifier. Those are quite tricky because they have to have a relay in them as well. So when you're transmitting, that it actually switches away from the active part of the amplifier, the no noise amplifier. That's for the receiving end. So that's where the sequencer is also there to switch off the preamplifier once the amplifier goes on. On the amplifier side, with the 1.5 meter dishes, I'd say 100 watts is sort of the minimum power you have to look at to do effective EME, to work a lot of guys. Now, when was it? I think it was February, we had the ARRL EME contest. And the amount of activity that was created by the guys that actually came on the air with solar cookers, these 1.5 meter dishes. All of a sudden, Europe and America became alive with stations where everybody thought you had to have a big dish, 3, 4, 5 meter dishes to the EME. With these solar cookers, they came on the air and it worked, and they worked a lot of stations. They even qualified some of them for the top 10 results with solar cookers. So they're very, very impressive. Amplifier side. Now, you won't find amplifiers in ZS. You won't find it in South Africa, unfortunately. So most of my amplifiers I've imported from this guy in the Netherlands, old Bert, and he's got a lot of options. So here you can see, let's look at the 100 watts. The 1 watt in, 100 watt out, okay, that's sold out. That's been replaced by the 2 watt in, 140 watt out for the same price. Um, then there's a 175 euros. So 175 euros is probably 1,700 times to about 4,000 rand. It's not too bad. And then if you want to do digital modes, you have to, for JT65 or Q65 or that TV, you're looking at the 225 euro one. What that one does, it includes a copper base. See the case with the copper bottom, and that's just to spread the heat better. So you mount that onto a heatsink, and then you can operate quite nicely on digital modes. So without that copper heat spreader, you have to be careful not to overdrive the amplifier or run it too hot. But with the copper heat spreader, it works a lot better. Here is a 23 centimeter 150 watt unit. So they get a little bit more expensive, 250 euros, and 8 watt in, 150 watt out. They normally all of them run on 28 volts, so you can have to buy a 28 volts or make up a 28 volt power supply. This is only 11 amps. It's not so much. And then you get to the bigger ones. It gets bigger, yes. This is a 250 watt unit. So 3.5 watt in, 250 watt out at 28 volts. They get quite pricey. This one is 520 euro. And you can even buy 2 of these and put them in parallel. And then you'll be running about 500 watts at the same voltage, double the current, of course, and have sufficient ventilation on your heatsink for that. So there's many options. And then you get the ultimate bigger, which is out of the States. This is a 600 watt unit, LDMOS amplifier on 1296. Very, very expensive. You're looking at about $850 for this one. But the guys buy them. I promise you, if you get addicted to that, the guys buy them. And yeah, you get the bigger dish later on, and it's just to get into it. You know, this one for 600 watt out, you need about 7 to 10 watt drive for 600 watt out. So the options are there, just like everything else. If you go into golfing or scuba diving or cycling, if you want better, you have to spend more money. But to start, 100 watts is more than enough to get into it. Right, once you have all that, then the fun starts. So all the guys are using the HP9Q logger. That's to find stations that's online or busy calling CQ or make skids. So it's not very, you can do it randomly. If you use a Q map, inside WSJTX, there's a additional package connected to it called Q map. And what you do there is you split your receive end via a normal RTL SDR into this package. And that will show you everything that's happening, every person that's calling. If you don't use that additional SDR, then it becomes a little bit harder. You have to find the frequency that the guy is working on and then go onto his same frequency. Normally the mode is Q65. And we use Q65C or Q65B. So in Q65, if you go to the mode Q65 and WSJTX, you'll see over here, there is the options that you can select. 15A, 15C, 30B, 60C, 60D, 60E. So different bands have different um, modes that they use for enhancing and being more sensitive. So on 23 centimeter, we use 60C or 30B. If your station is a little bit small and you want to work, say, maybe a 1.5 meter dish wants to work another 1.5 meter dish, it has been done. Even 1.5 meter dishes has worked 1 meter dishes. There's another mode there called 120, so 120. And the two circuits is a little bit longer, the two periods, but it becomes a lot more sensitive, and you can make a contact with 120. That's 120 seconds. Now, drift plays a huge role on 23 centimeters and higher. Doppler shift is a problem, so you cannot really do it without using the WSJT software. Even if you want to do CW or SSB, it's still good to have the WSJT software just running by the side because it tells you where to work who. So in the astronomical data sun moon tab, you'll find that it gives you the date and the time UTC. It tells you the top azimuth and elevation is where the moon is. Then you get your self Doppler. If you go a little bit down, you'll see there's DX azimuth and DX elevation and the DX Doppler. So this one I screen grabbed just on 6 meters. So you'll see the Doppler is minimal. I'll show you just now on 23 centimeters what the Doppler is. You can see there at the bottom there is the distance to the moon, 400,000 kilometers, and the degradation is -5. Now, in that astronomical data tab, there is an option there to tick that says Doppler tracking, bottom left corner. The moment you tick that Doppler tracking, that little screen expands to the right-hand side, and there you'll see full Doppler to DX grid. You want to hear your own echo, constant frequency on the moon, on the DX echo, if you just want to call DX, and then you can also do none. All of this will be handled by the radio, by the software itself. So it will do that for you. You don't have to do much there. It will do the Doppler tracking. We always use constant frequency on the moon. So both persons, if you're on 1296.065, for example, that's your frequency, and the Doppler shift, the software will calculate that both of you, when you transmit, you actually transmit exactly on top of each other. So you don't have to go looking all over for the station. Doppler shift can be quite wide. And the higher in frequency you go, the worse the Doppler shift becomes. All right. This was just a screen grab I grabbed on PSK Reporter during the ARRL EME contest. Now, you might think it's 20 meters or something like that, but this is 23 cents EME. You can see there, myself, I was quite busy in the bottom ends of South Africa. Bernie came on for a little bit and he operated. And then you can see Europe is quite busy. Japan is quite busy. Australia, not very busy. And then North America, extremely busy. And the reason why it is so different, obviously the Southern Hemisphere has got a whole lot less stations. South America, South Africa, Australia, New Zealand, there's a lot less stations active on EME in general. But the moon moves through the sky. Every day if you go out, the moon will rise in a different position. So when the moon is, they organize these contests. Even the Dubas, the European contest, they organize them for the contests to be when the moon is in the north. That means they've got more moon time than we've got. So our moon will rise, let's say 6 o'clock in the evening, and instead of being up for, let's say, 12 hours, it's only up for 8 hours. So we've got a lot less moon time compared to them. If the moon is in the south, then a lot of them can't see the moon again because the moon is too low for their elevation. And our elevation Yeah, the moon goes up to 88 degrees sometimes, which is basically right above us. And then they can't see the moon. So they don't really come on to the bands when the moon is in the south. So not all weekends are EME weekends. All right. Normally 2 weekends out of the month are good. Also, if the moon is in the north, more stations are on versus in the south. And then if you download the software called Moonsked, this is one of the things you can pull out of there, and that's called the moon graph. It basically tells you where the moon is in relationship with noise behind it, range, and degradation. If you look at that picture, you'll see the 10th. The 10th was yesterday. And those, if you take that bar graph to the top of that 10, you'll see that everything is high. The moon is far, noise is high, degradation is high. So during the course of this coming week, the moon is going to move. It's going to actually come very close to the sun. It's becoming new moon. So there where you see those two little sunspots above the 17th and 18th, that is where the moon is so close to the sun that if you beam to the moon, you actually pick up more sun noise than moon noise. You can actually detect moon noise as well on the higher bands. And the sun background noise is so strong, you will not copy other stations because it just overwhelms everything. So the 17th and 18th will be not good. And then starting on the 19th, 20, 21, 22, 23, 24, right into the 25th, 26th, all of those will be good EME weekends until it goes up again. So normally 2 weekends out of the month is good for EME. Yeah, which make it nice. And the other 2 weekends, you can build stuff or rectify stuff, and you don't have to miss out on moon time while you adjusting or bettering or improving. Right. Like I said, we use Q65. This is just a screenshot that I made during some weekend that we were on. These are KG0D and a couple of stations just calling CQ. I worked there. I worked one of them. Um, you can see he copied me at minus 29. So that's FT8. If you look at FT8, the best FT8 will probably go to is maybe minus 22 in sensitivity, but Q65 is a lot more sensitive. So this is a screenshot of my activity there, and I was just monitoring other guys. Sometimes you come on and there's a lot of guys on, and you've worked all of them, and you don't want to work there. You want to give them a chance to work somebody else as well. So on the left-hand side, you'll see the time and UTC. Then you'll see the signal strength minus. Um, that actually goes down to the bigger stations. It goes down to -1, -2, 0, +1, +2. And normally if it's like -1, you can start doing SSB. You can actually make an SSB contact with the stations. So you can see this was also made in Q65. You can see that in the middle at the bottom, there's 30B is highlighted in green. So this is a 30-second sequence that we use. So the contacts go a little bit quicker compared to a minute sequence. But if you're running a 1.5 meter dish, you'll probably always use 60C because it just gives you that little bit more sensitivity because of your smaller dish. All right. This is what the wide graph looks like. Now, you'll see this is a 30-second sequence. And if you go back to the screen, you'll see there in the middle, below erase, if you go down there, you'll see TX, and there's a frequency there, 1057, and then there's RX, 1231. So that's where you're TXing and RXing. Now, if you go back here, sorry, that way, you can see this is the TX and RX are both set on 1500. So if you use constant frequency on the moon, you will also advertise that you are calling on 1296, 065, 1500 hertz, constant frequency on the moon. And then the stations will look for you there and they'll find you there. You can see there's a couple other stations here as well. On the left-hand side, there's a couple of dots. He was running 60 seconds. And then I moved over to this 30-second period. Here I was just monitoring, so you can see that you're actually picking up every sequence. Somebody else was working him, so exactly on that same frequency that he is on. If we go, this is just a photo I took with my phone, guys. Sorry, so it's not so good. I didn't make a screenshot. I just wanted to send that to a friend. This was during a de-expedition. And there's a lot of de-expeditions on 23 SEMs as well. So the guys go to remote places and they set up station. Normally it's a 1.8 umbrella type dish and about 250 watts. And they'll activate that country on 23 centimeters. So you can see there's a lot of stations calling here. The blank ones where you don't see any dots, that's when the expedition is calling. And then the other one is where the other stations that's calling the expedition, that's where they're calling. So they spread out, so they're not all calling on the same hertz frequency. You can see they start there at 600 and they go right up to 2000. So if you take your little green line and your receiver, your mouse, and you click on that and you click decode, it should decode each one of those stations and tell you who they are and where they called from. So yeah, it's quite interesting during the expedition when everybody calls at the same time. All right. Now, I'm not sure. I'm not sure. Maybe Hans, you can just help me quickly. When I shared, did I share it with computer audio or not?
Yeah, you do. You should do. Play
So
the video. I tried that with somebody the other day and it worked. So click.
Okay, let's just see if we can hear this. This is the SSB contact. Oh, now it's got ads first. Sorry about that. Before I carry on, can you hear the audio from that?
I haven't heard any audio.
Okay, let me just put, yeah, it's in my earphones. So I'm not sure. I think in Teams, you normally always have to share with computer audio. I'm not sure in your platform. But yeah, if you just go to, I'm not going to play that then because you can't hear. So if you go to YouTube and you just Google 23 SEMS EME SSB QSO, you'll get this and you'll actually see where the guys make 23 SEMS SSB contacts. So it's not all digital. You can also do it with SSB. Okay, let me just get that back. Okay. So I'm not going to play that then. Seems like you can't hear it. Right, so there is lots and lots and lots of information on the web. Guys, there's Facebook pages for EME, so you can join that as well and ask questions and see what other guys are doing. There's a lot of information on soda cookers. So you can go onto the web and find information there, how to build your station, where to find your preamplifiers, where to find your amplifiers. You can contact me. I think maybe that's the easiest. You can contact me on zs5ham@gmail.com or on my cell phone, 082-852-8552. And I'll be able to tell you where and what you can get. And maybe there's one or two guys that want to do the same thing, and then we can import together. I'm at the moment busy importing a 3-centimeter amplifier from the Netherlands. So I have to pay the shipping myself, but there's a couple of guys that want to do it together. You know, you divide the shipping by so much, and it works out a lot cheaper. And also what's nice in importing ham radio equipment, most of it, there's no duties on it. You have to pay VAT on it, but there's no duties on it. So there's special codes that you have to give, and as long as they know that code, then you don't pay duties on it. So Any more information that you guys want or questions? I'm here. Anybody wants to ask something, I'll give you a quick time to ask some questions.